Part D, special angles in the unit circle. The unit circle can be used to very quickly evaluate sines and cosines of any of our good angles, angles that are multiples of 30 or multiples of 45. Before we get into that, though, I just want to review where all the angles are in terms of both degrees and radians. Starting with degrees, I have 0 degrees over there, 30 degrees, 45 degrees, 60 degrees, 90 degrees, 120 degrees, 135 degrees, 150 degrees, 180 degrees, 210 degrees, 225 degrees, 240 degrees, 270 degrees, 300 degrees, 315 degrees, 330 degrees, and back to the starting place all the way around the unit circle, we have 360 degrees. Writing these now in radians, 0 degrees is the same as 0 radians, 30 degrees is pi over 6, 45 degrees is pi over 4, 60 degrees is pi over 3, and 90 degrees is pi over 2. 120 degrees is 2 pi over 3. 135 degrees is 3 pi over 4. 150 degrees is 5 pi over 6. And 180 degrees is pi. 210 degrees is 7 pi over 6. 225 degrees is 5 pi over 4. 240 degrees is 4 pi over 3. 270 degrees is 3 pi over 2. 300 degrees, 5 pi over 3. 315 degrees is 7 pi over 4. 330 degrees is 11 pi over 6. And 360 degrees is 2 pi. Because we're going to be using radians much more often than degrees, you really do need to have this unit circle in radians memorized. You need to be able to very quickly be able to identify where any angles are. A few tricks for memorizing these things. First of all, notice that all the angles that are not horizontal but closest to horizontal, over here and there, and there, and there, are all angles over 6 in radians. Pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. The angles that are closest to vertical are all over 3. Pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. The angles directly in the middle are all over 4. Pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Closest to horizontal is over 6. Closest to vertical is over 3. Right in the middle is over 4. Next, the numerators. We have pi in all the numerators, so I'll ignore that part. But notice in quadrant 1, the numerators, other than the pi, are all 1. 1 pi over 6, 1 pi over 4, 1 pi over 3. In quadrant 2, notice that the numerators are 1 less than the denominator. 2 pi over 3, 3 pi over 4, 5 pi over 6. In quadrant 3, the numerator is 1 more than the denominator. 7 pi over 6, 5 pi over 4, 4 pi over 3. And in quadrant 4, the numerator is 1 less than twice the denominator. 11 pi over 6, 7 pi over 4, 5 pi over 3. We can use these two tricks together to be able to identify some angles fairly quickly. For example, if I was to look at this angle, I know this is closest to horizontal, so it should be something over 6. And I know I'm in quadrant 3, so the numerator should be 1 more than the denominator. The denominator was 6, so the numerator has to be 7. 7 pi. 7 pi over 6. The next thing we're going to do is we're going to put the unit circle on our xy plane. Y-axis over here, x-axis over here, and I'm going to assign coordinates to all the angles around the unit circle. We're going to see that these coordinates will end up being the x-coordinate is just the cosine of an angle, and the y-coordinate is just the sine of our angle. First of all, realize that we're on the unit circle. So the radius of this circle is 1. That means when I'm at an angle of 0 degrees, 0 radians, 360 degrees, or 2 pi radians, my coordinates are just 1, 0. When I'm at pi over 2, my coordinates are 0, 1. When I'm at pi, my coordinates are negative 1, 0. And when I'm at 3 pi over 2, my coordinates are 0, negative 1. What this means in terms of my cosine and my sine, the cosine again is the x-coordinate, the sine's the y-coordinate. So if I want to quickly find the sine of pi over 2, I just have to look at my coordinates and I see my y-coordinate is 1. The sine of pi over 2 is just 1. For the other angles, well, we can derive the coordinates using what we know about 30, 60, 90 right triangles. For example, 30 degrees, I can draw a right triangle that looks like this. The base of my triangle is not 1 because that 1 goes from the center all the way to the edge of the circle, which is not exactly what I have here. But I know that the hypotenuse has to be 1 since that's the radius of the circle. Well, that's across from 90 degrees. What's opposite 30 degrees has to be half of that, so I can fill this side in as 1/2, and what's opposite the 60 has to be root 3 over 2. At pi over 6, the coordinates of this point must be x-coordinate is root 3 over 2, y-coordinate's 1/2. So I'm going to get coordinates of root 3 over 2, 1/2. Doing the same thing for 45 degrees and 60 degrees, I would get coordinates at 45 degrees, or pi over 4, of root 2 over 2, root 2 over 2. And pi over 3 would give me coordinates of 1/2, root 3 over 2. The sine of pi over 3 is just the y-coordinate of pi over 3, so root 3 over 2. Before we move on, notice that there are only 5 values that show up in our x and y spaces. We could have either 0 or 1/2, or root 2 over 2, or root 3 over 2, or 1. Or another way of thinking about these values is root 0 over 2, root 1 over 2, root 2 over 2, root 3 over 2, root 4 over 2. Notice that 0 is the smallest, 1 is the largest, and we're increasing there. With this in mind, we can use some geometry to look at the unit circle now. Notice that at an angle of 0 radians, my x-coordinate needs to be the longest, so my x-coordinate there is 1. At pi over 6, my x-coordinate has to be the one a little bit less than that. That's root 3 over 2. A little less than that for the next x-coordinate is root 2 over 2, and then 1/2, and then 0. In terms of the y-coordinates, when I'm starting at 0 radians, I'm at a height of 0, so my y-coordinate is 0. At pi over 6, my y-coordinate's the one that's a little bit more, so 1/2. Then root 2 over 2, root 3 over 2, and 1. I can now use some symmetry combined with what I know about sines in my second, third, and fourth quadrants to get the coordinates of all the other angles. At 120 degrees, my x-coordinate has to be not 1/2 like it was at pi over 3, but negative 1/2 since I'm moving to the left to get there. Negative 1/2, root 3 over 2. At 135, I have negative root 2 over 2, positive root 2 over 2. Sorry about that. At 150 degrees, I have negative root 3 over 2, 1/2. And I already filled in 180, or pi, as negative 1, 0. At 7 pi over 6, let's see, I'm going down the shortest amount and over the longest amount, and both have to be negative, so my coordinates there are negative root 3 over 2, negative 1/2. 5 pi over 4 will give me negative root 2 over 2, negative root 2 over 2. 4 pi over 3 will give me negative 1/2, negative root 3 over 2. 3 pi over 2 already has 0, negative 1 as its coordinates. 5 pi over 3 will be, okay, so now my x-coordinate has to be positive, y is still negative, so 1/2, negative root 3 over 2. Root 2 over 2, negative root 2 over 2. And root 3 over 2, negative 1/2 when you're at 11 pi over 6. If you can memorize the coordinates of all the angles around the unit circle, it's going to make evaluating sines and cosines a whole lot easier. On any test or quiz that we have that involves some trigonometry, I'll let you use a blank copy of the unit circle for you to fill in whatever information is helpful for you so you can evaluate those sines and cosines very quickly.